we now need to actually add the 5 signals that we've created to the controller. This is done by navigating to the Controller tab, to Configuration, then down to I/O System. This shows you all of the properties of the inputs and outputs of the ARM. Navigate to Signals. This shows you all of the available signals that the controller actually has. We can now add our own digital signals to this list by right-clicking anywhere in the box and clicking on New Signal. From here we can add our 5 signals, making sure that we use the same signal names that we define in the instructions and ensuring the right type of signal is configured using Type of Signal. Name the first signal Open Grip, and since this is a digital output, set the type to Digital Output. The default value is set to 0, which is correct for our signal. RobotStudio is letting us know that the signals will not be added until the controller is restarted. Click OK. Repeat this process for the other 4 signals. Now we can restart our controller. To do this, right-click on the ARM in the Controller tab, go to Restart, then click on Warm Start. This restarts the controller and confirms any changes we've made to the configuration of the controller. Now, set the path as an entry point and sync all of the changes that we've made to the controller. RobotStudio has a built-in I/O simulator, which allows you to change every input and output signal in the controller manually. We can use this simulator to control our signals to ensure that the logic of our program is correct and works as intended. To do this, navigate to the Simulation tab, then click on I/O Simulator. This shows the simulator pane on the right with the available inputs and outputs. Press play to start the simulation. First off, looking at the path, the ARM is currently waiting for the Start Sim signal to be set to 1. To find Start Sim, since it is a digital input, click on Filter and click on Digital Inputs. Now, not all of them are currently listed, so change the I/O range to all. You can see our 3 digital inputs that we've added manually. Click on Start Sim to change the value from 0 to 1. As you can see, this has progressed the simulation further, so that the ARM is now over the box. You can check the value of the output signals by navigating to Output Signals. As you can see, Open Grip has been set to 1, as instructed. Now the ARM is waiting for Grip Opened to be set to 1, so navigate back to Digital Inputs, down to Grip Opened and set to 1. The gripper is now at the box, waiting to close the gripper. Again, you can check the status of the output signals to see if it's changed. Open grip is set back to 0 and close grip is now set to 1, as instructed. Now, go back to Inputs and click on Grip Closed to set it to 1. The ARM moves back up and over to the platform. Keep checking the status of the open grip and closed grip signals. Closed grip has been set back to 0 and open grip is now 1, instructing the gripper to open. Now, go back to Inputs and set Grip Opened to 1. The arm moves back to over the platform and back to the home position. We've now programmed our arm through the correct motion path and have set the signals to open and close our gripper at the correct point in the path. However, there is one glaring issue with our whole program. The arm doesn't actually open and close the gripper and pick up the object. If we are working with a real robot arm, the current programming is enough to actually do what we have designed. However, since we are working with a simulation, we have to design our own simulation scenario, where the gripper can actually physically hold onto an object, and where the gripper can physically open and close according to the input and output signals that we've set. This is where we introduce station logic and smart components to our program.